Hello everyone. So I have a little extra time today, so I'm going to try and do a little more streaming. Um, yeah, my animation sprint ended a little sooner than I would like, but I still have sporadic time now and again. So let's get onto it. So I figured rather than trying to like build this tool any better, it's not completely GUI driven, but I have enough here that I think I can make a I can do the code part of it and get something working. So if you are just tuning in, this is where I left off. I have this tool here that I made where I have, I'm creating a scene explicitly by, just declaring what's in the scene. And then, so here I say, well, make a element that's a square, and then it has this background color and this border, and put it in a particular place, and then add a track for that, and then here are the keyframes, and then here's another thing, here are the keyframes for that, and here's the keyframes for the rotation, and put all that together, and you get this little animation here, and then you can slide this back and forth, and so far it doesn't actually like export anything, and that's probably the main thing I really need to make it actually useful to me, because I can get by with using code as the user interface for a while. So that's what I want to do right now. I want to make one of the animations that I actually wanted to make this whole time. So I did a stream a while back about this Pathmap data structure. I don't know if you can really even call it a data structure. It's just an array, right? So what I did to make this video is I ran this thing, and you get this, and this view is a little finicky. So once you start moving it around, yeah, you're no longer able to drag the guys for some reason. I'm not entirely sure what's up with that. But the idea is that, well, you've got power of 2 minus 1 objects in your array, and so that's how long your array is, and then it's designed to act as a binary tree. So you've got a 3 here, and of course it doesn't have to be binary, and the rules are slightly different when it's not binary. If it's binary or whatever, you can have it depth anything. Yeah, you can have it. The degree can be whatever you want. But I want to make it's a flat array, but it really represents this data structure, and you get these kind of links for free just based on the index. So as the famous song goes, you store your data in a sparse array, and you calculate your index using plus and times, right? The song is not famous yet because I haven't made this video, but there is a logic to this that is just basically simple arithmetic determines what slots in the array are parents of what other slots. So I want to illustrate that, and I want to make the animation that I kind of just did by hand here, where I've got a selection of the array being moved up on top, and you can see the structure emerging from the linear, the original linear point of view, and then you would keep these lines together as much as possible. So I don't know if I can do that. I don't know if that's possible. I don't know if when the thing that is providing the lines is called Mondrian, and as you can see, as soon as this zooming view got involved, like you can no longer move anything. So I don't know if that's because something is like intercepting these events and like covering it. I don't know what's going on here. So I guess that's something I need to experiment with and find out. Yeah, because even moving it around a little bit, like it seems to trigger this zooming view here, even though it's not zooming. It's a zooming and scrolling view, and so now Mondrian is broken. Whereas if you just run it, then now you can move you can move these pieces around. So I don't know exactly what's happening. Could be some some of the constraints are not working correctly, so that this isn't working. I just don't know. So the first step would be how do I create the scene and then animate it? So I think I'm going to make that an example. So well, first of all, I guess I should check that I think I'm up to date. Like I don't have any changes that haven't been checked in or whatever. I'll just double check that. So if I go to Git, it looks like, excuse me, if I click on TS Faro, it looks like everything is up to date. Block book is not up to date, but that's fine. Block book is just my notes on this GUI environment. All right, so all right, we're all good. So I think what I want to do is I don't need GS demos. I just want to get. Let's close all this and let's find a. Well, I guess we would start with GS animator examples. We're going to browse that class, and right now we have the bouncing square. The make. If I just none of these are actually tests. Oh wait. So I didn't actually mark them as examples. Just if I call this a GT example. If I mark these as being examples, then we can run them and chain them together. It does nothing other than provide some extra UI elements up here. I'll call this a blue square. I'll save it and then I'll rename it to blue square. Blue square. Now you see there's this little gray box next to it, and what that means is it's a example now. I think if I browse this again, it'll have some extra. Yeah, see it says examples up here now. If I run this, then it runs those. I can run these and they all pass because there are no assertions in them. But let's make all of them examples. And we'll make a path map example. Okay, so maybe I'll commit that. Boom. Examples, and then we can run all the examples. And then now you can actually click on this and how do you get? You click on here. Result. Yeah, so you can see the results of running it. But it didn't have any keyframes. So seen with the square doesn't have any keyframes. Bouncing square should have this, and then you say result. Oh, okay. You run, yeah, sure. Not sure why it does that. All right, well, whatever. Blue square. That's just a blue square. A scene with two moving squares. You have to go. Yeah, I'm a little confused. Maybe I didn't quite do this right. Can I child that is art? Yeah, why not? Maybe you have to run them again? I don't know, that's weird. There you go, okay. All right, so let's make a new one of these. And I think, yeah, I'm gonna check that out. Marked, make blue square, I'll rename it, yes. So GS animator, mark examples as examples. Add GT example practice. Right. We can just push that up to GitHub. It's github.com tangenstorm TS Pharaoh. TS-Pharaoh. Okay, so what happened to my right, well, I guess I closed the Pathmap demo thing, so or maybe it was, yeah, that was it. I was looking at it. It was one. It was on the left over there. Pathmap Animation tab. And I had been looking at this, and then that changed the name of it. Yeah, it changed the name of the top. Okay, so I want to add a new thing over here in the examples. I want to say, so we'll add a text snippet up here, and we're going to make a new method over here that I'm going to expose in this text. So the method is going to be called what? I guess scene with square. We're going to say pathmap scene. Say pathmap. I'm just going to rename this, or not rename it. If I change this, it'll make a copy of it. So pathmap scene, and I will say pathmap, and we'll say pathmap is equal to GS pathmap demo new degree 2 depth :3 degree 2 semicolon depth :3. Why didn't that not work? GS pathmap demo. GS, oh, because I still have a field element with a size here, so get rid of that. And then we'll call this demo. Demo. Let's go down here. Demo equals this, and then basically copy this. And then Mondrian as element as pathmap. And we don't need the actual variable for it. So I think if I run this, we should get something, right? We should get, okay. Okay, that's a little weird. I wonder if I can just move it around within here. Yeah, see that? That kind of makes sense to me. But I have no names for these things. I think maybe what I should do rather than having Mondrian create the scene, I think what I'm going to do is actually I don't know what to do. See, so it's created a scene. So when I say make graph, right? Make graph layout. I can't. If I browse the implementers of this, I'm going to create a GT monitoring. So monitoring is not a block element. Monitoring is a thing that orchestrates the block element. And when you say as element here, it just gives you the scene that it has created. It gives you the root of that scene. And it detaches it from its current parent and gives it to you to do as you like. I think I don't need this word as element here anymore. Let's save this and see if I run these. Oh, no, I did need it. Okay, so that. Wrong. Oh, I did something called GS node, but it's basically the same thing as a GSL, but you don't have to give it that name. GS node, but oh. Okay, well, maybe I don't want to mess with this. Okay, just GSL. GSL for the number as element with background. Okay, so whatever. I browse this class and I say, what is nodes? It's going to give me back a node builder with a new node builder with monitoring set to the self. If I browse that class, when it does width for each, with the collection for each block, okay? Mm-hmm. Created elements. So loop through the created elements. I've never used this. I've only just used width. The point is that width takes a bunch of x's. So x is these numbers. And then we're going to just create a node for each one, and then the node has that particular shape. Node element 4 uses the stencil builder. It's something that we use with when we say shape, right? The graph builder has something called shape, right? It's the same as stencil. Hey, sweetie, what you doing? A fruit snack. Wow, you got a lot of fruit snacks. Sure, I'll take some. A whole tray? I'll just take some. I don't need a whole tray. Thanks. Fruit snacks. All right, I'm on camera here. I'm making a video. Trying to figure something out.
You can put them in this bowl.
Okay, I'll put them in this bowl. Thank you. I'll be down in a little while, sweetie. Okay. Thank you. Bye. Yes, please. No, you don't have to close the door. It's quiet. You're not making much noise. Here. Okay. Sounds good. Thank you. Okay, so anyway, I think that when you say node builder, so this each is the value, the object, right, that you're making an element for, and then I guess there's some kind of dictionary here, node at dictionary name. No, that's an XML thing. Oh, trains graph, put a node element. Yeah, objects. No, this is what I'm expecting to see. So I suspect it's this. Something that maps a number or the value to the element so that you can look it up that way. But what I was really getting at is that somewhere in here, when you say node element for maybe, yeah, it's this thing, B node. Node element graph B node. The node element is you're going to run the stencil builder, and you're going to pass it an object and the default node element. Default node element. Oh, so you give it a default node element that actually creates one, which is just some little black box usually. Yeah, just by default it creates a little tiny black box, a 5x5 black box. No, it's a white box with like this. Yeah, so it looks like a little tiny black box with a circle with a dot in it, like a little tiny black box with a. If we inspect this, you can see this, right? So if I just say Control G on this, you'll see it. It's very hard to see, but to me that this isn't zoomable, but if you zoom in, preview maybe. Yeah, it's like got a little tiny dot in it, so it's like a black box with a dot in it, with a white dot in it because the border is so thick. Okay, so that's their default node element if you don't specify your own, and I guess you can just do whatever you want with that if you give it a second parameter in your stencil builder. But otherwise, you just get that's what call means. Call means is you can pass in an argument, but just ignore but if the block doesn't actually take an argument, just ignore it. And otherwise, if that is nil, then just give the default element. Okay, but then it says graph model is an object. So this could be any. So this is something that is on every single BL element, right? You should be able to say BL element new model 52. Oh, but graph model. Graph model 52. That should just work. So graph is just something that's on every. So graph element context. Okay, so that this is like a magic thing that is on every single VL element. And if you say that, it just adds this graph element context on self. It says self new element is an element, and then return yourself. Okay. The yourself is redundant here, but okay, and then model is something on this graph element context. Sorry, I want to control B to browse that. So I'm a utility class that offers an extra API for adding graph semantics to block elements. Okay. Toolkit block graph. So this is something even more primitive than Mondrian, or more primitive than Mondrian. Edge children, node children. Interesting. And then you say be a node. And then you add the pull handler, and that's what allows it to move. So that's very simple. Okay. So if we go all the way back over here, like we now understand where the. So I'm going to hit check mark on this, and then I think I'm hiding a name here. No, I guess not. Maybe I was on. But I now understand. So well, I explicitly tell it to make a GSL, but like all the extra behavior that we're getting from Mondrian is from that B node and make it pullable and all that stuff. So Mondrian added this ability to move things around like this, and it adds these edges or whatever. Okay. Connected if true. Give that Mondrian. Mon being this thing right here. Mondrian nodes. On layout perform a symbol. The layout is horizontal or tree or whatever you want it to be. But I'm guessing you can control M on that, control B. Initialize has got to create a root, right? A VS canvassable element, new, enable auto scale in a root element, padding, all that stuff. And that's why that you get that white block there. Right, so if we just said GSA equals it becomes GS animator new, right? And then we said graph. Can we get the Mondrian? No. So right now we would have to say initialize, and then we would have to say Mondrian equals PT Mondrian new. Then we'll make that a. Oh, okay, yeah, we'll use that, and then we'll actually rename it. I think it should be called Mondrian. Mondrian. Right, there's a bug with this that if you try and add, yeah, if you're not very careful and you like retype what's already there, it screws it up. All right, so Mondrian, and now here we return Mondrian, and rather than doing this, we're going to say we're going to erase this line and use the one from initialize, because now I can say, I can intercept that and I can say, oh, well, we should expose a accessor for that. I just want a reader, so Mondrian, return Mondrian. And then we'll say GS is GSA animator, and GSA Mondrian root. Sorry, demo equals this, and then demo Mondrian root is GSA scene. And then we just return scene GSA scene. How about we make a root? We explicitly make a root. Or Pathmap. Or root. Well, I don't. I'm not sure. Let's just ignore that for a minute. So add. We shouldn't have to say this anymore, because the scene should already exist. And we want to return GSA. We want to return. Right, the scene with square actually returns a GS animator, right? And this says we return a GS animator. So we don't actually need this, just demo make graph true, and we don't actually need the Mondrian now. We don't need the root. Okay, so I think that is good. I think if we do this, then we get everything we had before, but now there's no white box and it won't slide around like that. Did not understand root. I could have sworn Mondrian had a root. Okay, so let's browse GT Mondrian. GT Mondrian. It does not. Initialize root. Where's GT Mondrian step? Oh, we have to say top step root. Top. Yeah, so root returns self top step root, and top step returns the stack thing. So when in the initialize, we get a GT Mondrian step, and it does look like there is a root method on there with enable auto scale. Maybe we want that, maybe we don't. I don't know. So Mondrian top step root. Run it again, save it, run it, see what happens. Boom, there we go. Those do seem, that all seems to work the way I expect it to work. Okay. That's nice. So now let's actually, let us do make a root. And the root will be root. And root going to be not GSA scene, but rather we're going to add GSA scene, or rather add scene child root as root. And then root is something. What is root going to be? Root is going to just be a VL element. VL element position 320. No, you can't say position. You say first we say VL element new, and then you say relocate 320 at 240. And then transform. How do we do that again? There was some way you could transform center origin. Transformation builder. I think you just say BL transform center origin. Transform center origin. Root transform center origin. I think that works. Root add child, and I'm just going to say demo Mondrian default node element. Default node. Just to put one in there in the scene. Not understand default node. Yeah, what does it understand? Nodes. Oh, it's on here. Nodes default node element. Default node. Mondrian nodes default node. Yeah. So that's just showing where the center is. Interesting. Let's say GS object new. Match parent. And I'm gonna give it a weird background. Background color red. My wife is calling. I'm sorry, I'm going to decline her for a second. Better, I'm streaming. Okay, so that's doing a fit content rather than the if we say GSA scene match parent, what happens there? I think something is overriding this and causing it to fit the content rather than maybe after we add the Mondrian, then we'll just say root match parent. Yeah, that makes sense. I wonder if this is. Huh. Root. Maybe center origin doesn't do what I think it does, because I would think root. If we add this here, right? Root. That's the center right there. That makes no sense. Root add event handler field full handler. That should make it draggable, so I can drag it around. So I can drag this around and see what whole thing at once, right? Yeah, I'm expecting it to be exactly the size of that scene, but I would expect that to. Mondrian is making this a horizontal layout. That's why. So forget Mondrian for a second. And so instead of making the graph, we never make the graph. Then I think this. So center origin does not do what I think it does. Center origin centers the origin within the parent. Right. And so if I say root add child okay, I guess I'm being silly, right? What do I I'm just experimenting here. It makes no sense. Say match screen. GSA add. All right, so if I run this right now, I get that, and if I add this thing, get that, and if I say match parent, get rid of that, it should, yeah, instead fit the content. I don't need to add this little element here. And I don't need, if I get rid of this though, what does it do? Nothing. Okay. So I need the root to be something centered with, okay, so I do need this. Because I want all these things to move around on top of that red thing. So root match parent. root match parent. And so I guess what I would say then is top left origin, but not like that. You would say, first of all, capital O, root match parent, and then transform top left, root transform top left origin. I'm not entirely sure why that's different. I guess you can't add on to a cascade after the first one. Like once you're in a cascade, you can't just start. Whatever. So I think now this is going to be a big red square within this box, and then this will be up here somewhere. Maybe it's relocate 0, 0. And this has nothing to do with it. Okay, so that had nothing to do with it. All right, so but the whole point of doing this is just so that I know what I need to do. But what I really need to do is just say root clip children false. So instead of doing this, we just say root clip children false. And now if I run this, it's here, and then they can move anywhere. Yeah, that's exactly what I want. That's what I wanted to say. So I don't think I even need this. I just think I just need to relocate it to the center of the screen. Oh, maybe that is the. Okay, and what if I don't have this? Because this is also centering, right? What if I just don't do that? Boom. Okay, and if I say new, and if I say root transform center origin, does that do the same thing as relocating to the center, or what? No. Oops. I wanted to bug it. I feel like there's a better way to do this. Probably there is. But okay, so we can just say relocate here. We don't need the flow handler for this. I'm going to say clip children false. Root, and we can just say make graph true layout horizontal. And then return to this. Make graph demo. I didn't like that. lost. Okay, so oh right, because because make graph would not be, it's on demo, not on the top step. Okay, so that's that. I don't know why I'm doing this. As you have root equals as okay. You can say Mondrian edges and just change the default node builder. Mondrian. Oh no, you can just say here. You can say top step root demo Mondrian edges stencil. So if we say GT Mondrian edge builder, then we should see the default edge elements. If I just make this black, right? That did not seem to do anything. Probably because make graph is already giving it a no. Mondrian edges connect. Connected if true, Mondrian edges connect. So if I said demo Mondrian edges stencil, okay, so maybe Mondrian edge does it not have a stencil? Edge element 4 should cost element stencil builder value and object. Yeah. All edge element. Oh. So it should be shape or stencil. Or element stencil builder. My daughter is opening the door and talking to somebody. I gotta hang on. Who are you saying hi to? can wave at them, but just don't open the door for people, okay? Only 5. Okay. Hopefully this will put my face back in the right place. There we go. Magic of facial recognition. Okay, so yeah, I'll be down in a minute, sweetie. That's why I don't. I'm going to wrap this up a little bit, and I'll come back and do a part 2 in a little bit. I don't understand. That should absolutely work. Why isn't it doing this? Because it doesn't remember the thing. Oh, that's unfortunate. See, it makes a new one every time you call edges. Okay, I gotta go. I'll be back later.